So what is a vector? Well, a vector is a quantity, let's say 6 meters, that has a direction. So in order for this 6 meters to be a vector, it needs a direction. Let's say it's east. Every day we use vectors. When you're telling somebody where to go, you usually will tell them a distance, let's say 6 meters, and a direction, let's say west. So basically, by telling somebody, go 6 meters north, you're basically stating a vector. Now, in order to add and subtract vectors, you need to add the vector system, as seen here, tip to tail. So you make one line, this is the tip, and they make another line, this is the tail, since there are 2 lines in this system. One is 6 meters, so the 6 meter line, which is the bigger one here, is attached to the smaller one, which is 2 meters. It really doesn't matter which one is which one, as long as they're tip to tail throughout the entire way. So now here's what you do. You take the bigger one, you make it positive, since it is bigger. You take the smaller one, you make it negative, since it is smaller. And you add normally. 6 minus 2 equals 4 meters. Okay? Now, since 6 is bigger than 2, the direction will be east, since 6 meters is attached to the east direction. Now, to subtract vectors, you basically do a similar thing. Again, attach tip to tail. 6 meters east, 2 meters west. All you do is you subtract 6 meters from 2 meters. But there's a catch. You have to make 2 negative since it's in the opposite direction of 6. West is opposite of east. So basically in this case, you're not subtracting, you're actually adding. You're adding 6 and 2. 6, 7, 8. So the total in this case would be 8 meters. Yes, we're technically subtracting, but because one is in the opposite direction of the other, the total is larger than adding. Distance time graphs. Distance time graphs basically show the correlations between distance and time. Fun fact to note, as the line gets steeper, so does the speed. So it also shows speed as well. Now, you can use velocity time graphs to basically find the numbers in a distance time graphs. Well, you're still going to have the same time, but it lets you find the distance, which is very useful. You do this by basically calculating the area under the line in a velocity time graph. Speed and velocity. Now, speed and velocity are basically the same, so in this explanation I'm just going to use the term velocity. Now, there are basically 2 types of velocity. There's constant velocity, or uniform motion, and there's non-constant, or non-uniform. Constant velocity basically is, velocity never changes. So in a graph, the line would just be straight. It wouldn't have any slope whatsoever. It would never change. The acceleration is equal to 0. So there's not going to be any acceleration in this one. So if you have to find, let's say, time for constant velocity, you just get rid of a. It would be 0. So in non-constant velocity, there is a slope. There is an a. A is not equal to 0. It either goes up or it goes down. Acceleration is increasing, acceleration is decreasing. So in a graph, lines would basically have some sort of slope. You can find velocity 2 ways. Velocity equals distance over time, or you can use the kinematic equation A equals Vf minus Vi over t. Is pretty good, I enjoy that too. So that's basically what speed and velocity is. It's basically the same thing, it's just constant, non-constant. In conclusion, that is what a vector is. A quantity with a distance. That is how you add vectors, tip to tail. That is how distance time graphs look and what they mean. And that is how speed and velocity work. What's the difference between constant and non-constant velocity? So in conclusion, that's it.